Okay. Okay, guys. So, okay. Shall we start? Everything? Okay. Okay, guys. Everything okay? Let's start. So, yeah. So, how many of you have watched this video? 7.5. Means, I mean, you haven't missed this video, right? Large scale machine learning. Wait a minute. Okay. Am I audible, right?
Yes.
Okay. Okay. You can see my screen also, right? This I'm on NPTEL website. Sorry, not NPTEL. Our online based degree MLP course website.
Yes, you got it.
Okay. Okay. Shashi Kumar sir, please explain the chunking of data. It is not clear. Okay. Okay. Yeah, we'll do that. So let's do first this activity questions. So anybody has like any doubts, or should I just solve every questions? Uh, I guess I have to solve every questions. I think okay. Okay, so softmax regression algorithm is used for solving multi-class classification. Is it true? We can use it, right? So this one is true. And normalize an input vector into a probability distribution. Uh, okay. To solve multi-class classification problem using logistic regression estimator, we'll set multi-class parameter to. So in logis to solve multi-class, yeah, this from video, right? We have set it to multinomial. If you watched 7.1, it's there. Which one is a different algorithm? So this logistic regression and softmax regression. Uh, this one is also. So this KNN, right? KNN. So KNN is is algorithm which model doesn't learn anything. It just use all the data point, measure Euclidean or any distance, and classify a new data point. Right. Okay. Then accuracy score. So what is accuracy?
Uh, True positive plus true negative by
Yes.
total samples.
Yeah. So what will be that? So so this one, right?
Yes.
939 plus 11. Sorry,
Correct.
939 divided by 939 plus 11, right?
That is
Does this thing work? Okay, is there anything?
yes.
Okay. Okay, so right, accuracy. So we draw the like metrics, right? These are uh, predicted values, and these are true values, something like so. Like we have so it's not okay. So we'll do is if we want to calculate accuracy, like somebody said, we'll calculate how much uh, we predicted true from all the true predictions. Like means which should be true. So I don't know. The calculation will be 939 divided by 11. It will be around 0.988. Okay, 0.98898 is given, so we'll use this. Okay, which of the following SQL module implements confusion matrix? So matrix, right? It comes in matrix library. So I think maybe nobody has problem with that, this all questions, right? We can go to 7.2. Okay, which of the following SQL module implement relevant functions for nearest neighbor algorithm? Uh, Neighbor. Okay, neighbor. Okay, for every data set there exists a threshold k naught, so that increasing the value of k beyond this a threshold does not significantly affect the accuracy of the model. Of course, right? If I choose all the data set, uh, means I guess they are talking about KNN. Increasing the value of n beyond the threshold does not significantly affect the accuracy of the model. Yeah, they are talking about KNN only. So in that case, how many uh, yeah, how many neighbors do you want to select for new for classification, right? So beyond some point, nothing will matter, because all if all the data points are selected, then majority will always win. Okay, and let n denote the number of training data points. Okay, for every data set there exists some threshold n note. Okay, so the increase the numbers value beyond n, This threshold doesn't affect the accuracy of the model. Uh, Actually, it depends. Uh, but I guess it's kind of debatable because which class they are increasing, they haven't mentioned something like this. So one is true, but this one is should be more specific little bit. Okay. What does the value of k in k nearest neighbor refer to? So it refers to a number of nearest neighbor to consider for each test data. Like this one, right? Which of the following statements are true? Kn model with low value of k produce complex decision boundaries. Uh, if we have low value of means we are taking low. If I'm taking less number of votes, mm, then it will form a complex boundary, right? Yeah. Uh, yeah, it won't form a simple boundary. It will be very, specific boundary because small distances will make changes. Okay, can model with high value of k produce complex boundaries? No, that's not true. It will form simple boundary, like all the space will be in one color, one classification. Can model with low value of k produce simple decision boundaries? No. Can models with high value of k produce simple decision boundaries? Okay. uh, okay. Given kn can be thought of. So, guys, and do you have any problem in this, or should I just go and you know uh, do something like if you haven't understood something? Somebody saying expand the screen. Okay, is it? Then couldn't able to go below this. Okay, now I can, but now I can't. I guess maybe you know everything. Okay, which of the following SN object are relevant to perform classification using?
So could you complete 7.2 and check the answers?
Okay, you want. Okay, then we'll do it. Okay. So, which of the following SN model implements nearest neighbors? So, this one, right? In this, uh, statement 1 is true, but but if I increase the data points, mm, but then if my k is if I have decided k, then increasing the number of data points will not affect because I'm not taking everyone's decision, right? I'm making decision of few neighbors only. So in that way, statement true is true and one is also true. So what does the value of k nearest neighbor algorithm refer to? Number of data points to be classified, number of nearest neighbor to consider for each test data point, number of dimension of each. No, it's not dimension. Okay, so I guess number of nearest neighbor to consider for each test data point. Data. And this first and four, right? Simple. If we have more like more number of people to vote, then simple decision boundaries will be formed. And if we have low value of voters, like k means number of neighbors.
If case 2, that will only be a simple boundary.
No, if I'm taking, let's say, two neighbors, right? Then that small hole will be there, like
Yes, sir, but if you see multi-dimension, it could be in the third dimension, fourth dimension.
Yeah.
With as k increases, won't it get more complex? I'll get planes and get
No,
hyperplanes.
no, no. It's not about K is number of voters. If you see in the terms of voters, means let's say if I'm
Number of points, now clusters.
number of not number of clusters. Uh, K doesn't denote clusters. Clusters that is denoted in K means this is K
Okay.
nearest neighbors. So in
Right.
this,
So number of the neighbors where we are collecting, right? Number of
yes,
items that we're checking.
yes, yes. So if let's say if I'm taking all the, so how many number of data points are there? I'm taking votes from all of them, right? Then majority will always wins, right? So it will form simple decision boundary. Whoever is majority wins. There is no
Okay.
question about. And if I'm taking less number of voters are there, then it will form little bit like complex boundaries. Like around this point, uh, it will be. So if there is outlier in that, then you will know that yeah, around this uh, only like other classes there like that.
Okay.
Yeah. Okay. So if you have more than simply whoever majority is gonna win. Okay. A given test data point in KNN can be thought of as being situated at the centroid of K training points. Uh, I guess that's not true, right? At the centroid of K training point, nearest given test data point. No, it doesn't tell you where it is situated. Actually, KNN doesn't even tell you where it is situated. Maybe K means does. Okay, so if okay, are the K nearest data points, uh, then the predicted will be y of x1, sum it up, and I will divide it by k. Uh,
This is true, right? You
no,
take the mean.
yeah, this is true for this is for I guess regression problem, right? Yeah,
It's the mean, right?
yeah, yeah. So I guess D is the answer. Statement one is false, but statement two is true. Which of the following are false regarding KNN? Okay, KNN is a non-parametric supervised algorithm are false. We have to tell false. So this is true, right? KNN is a non-parametric.
K is a parameter, then the first one is false, right?
No, no, no. It's not talking about parameters. It's, there's something of parametric and non-parametric algorithms, right? Uh, see that parametric and the non-parametric.
Achha, I thought K was a parameter, right?
No, 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 it's not about a parameter. It's like parametric and non-parametric algorithm. You can
Okay.
read something like this, right? Okay. Okay. So this is true. So I can't check it. The number of KNN is parameter to be estimated from the training data. This.
So,
Uh,
so the question says how many of them are false. Okay, so
yeah. So this is true.
right, so right, okay.
We estimate K from training data only. Like we don't have any method to.
That means K is not a parameter, then it's a non-parametric.
No,
The second option should,
K
so
is a
we should
K is a hyperparameter.
hyperparameter. So the second one should be selected, right?
Ah, yeah, yeah,
That's
sure.
false. That's false.
That's a false. Okay. The time complexity of classifying test data point using KN depends only upon the number of training instances and not their dimension. Not the dimension.
This is false, sir, because dimension increases the complexity of Euclidean
Yes,
distance.
yes. The distance will be increased every time. One thing can model from the cause of dimensionality. Uh,
Yeah, complement of the previous top sentence.
yeah, it's true. So okay,
Okay, thank you, sir.
5. Okay, which one we missed? Statement 1 is true. And sorry, maybe I missed it. Beyond this point as well does not give significant effect. Uh, but actually, this is true, such that increasing the value of k beyond this threshold.
Sir, if k is equal to n,
Yes.
so if you
K,
look at that model, then the first one should not be true, right? If I keep increasing k to equal to n, that each point goes to a sub.
oh yeah. No. See, the thing is, after a point, let's say, so they are saying that there is exists a k naught, such that increasing the value beyond this point does not significantly affect. So I can, if I take similar to the number of samples I have, then after that the majority will always win, right? So the accuracy will be whatever majority, right? Then nothing will change.
Okay.
Uh,
I thought this was Gaussian, that there will be an optimal value after it again keep dropping.
okay. Okay, we'll see. I guess there is some one. I have to ask who designed this. Okay, let's go to 7.3.
Thank you for 7.2, sir. That was really little bit confusing for me. So thank you.
Okay, yeah, no problem. 7.3. Okay, which of the following SQL objects are relevant to perform classifying using k-nearest neighbor? Uh, relevant to perform classification using k nearest neighbors. So k nearest classifier will be there, right? And may, relevant. So this is also relevant. Mm, but it doesn't do classification. Okay, we'll see if something. Okay, which of the following is true regarding the weights parameter of the k nearest neighbor class? Okay, it is concerned with the parameter weight of the KNN model. Which of the following is true? Okay, it represents the relative weights assigned to each class label, which are to be considered during the majority vote. Oh yeah, I guess this one is true, right? It represents relative weights assigned to all the neighboring points as a function of the distance from the test point during the majority vote.
So yes, sir. I think that's good.
Because we are taking distance and all. I don't know the feature weight used in calculating the weight. K distance. No. Means distance is a different thing. Okay, the performance of a brute force k nearest neighbor algorithm critically depends upon which of the following factors. So there are like three thing like in k brute force, k ball, and kdt. So in brute force, we'll just simply calculate all the distances. K value, it depends because how many neighbors we are taking. Chosen distance parameter, distance metric. Uh, it does actually number of training points. Mm, brute force critical depends on the following factors. performance. So distance metrics will be there. Number of training points. How many points are there to train? So if I have more number of points or less number of points, the voting will change. Yeah, so this will also affect number of distinct classes. I guess that that won't change anything. Okay, see. Which of the following SQL object helps us find the k nearest neighbor of a test point within a given training set? K, this one, right? Neighbor. This is inside the k nearest neighbor, which will help us in find. So it will give us the coordinates of the nearest neighbor. Okay. Uh, and k neighbor transformer. I haven't used it, so I don't know. Have anyone used this, like k neighbor transformer? Let's see what k transformer. Thing is. Transform x graph x into a graph of k nearest neighbors. Transform data as sparse graph as written by k neighbor graph. Okay, so this can also give shape. Okay, shape. How many things we have? And feature name. Hmm. Uh, k nearest neighbor. So this is actually telling us that transform x means the data set we have training set into weighted graph of k nearest neighbor. So like a tree kind of thing it's doing. Okay, we'll see if this is true or not. It might be true. Match the following KNN on training set of 100 points. Okay, so if I have, let's say, more number of points, then I am not fitting. So means less fitting is required, right? And if I have less number of points, then the hard, like complex boundaries will form. Means we are doing overfitting. Okay, so for one, I'm doing overfitting. So A, and because if I overfitting, then there's possibility that it will show high variance also, right? So AD for first one, and for two underfitting and low variance. Okay. Three. Okay, which one? Both. So okay, so this one also helps us in finding neighbors of a test point. Okay. We'll look at this one is okay. And in this chosen distance metric, so k value. Why is it not depending on k value? No idea. But it does, right? It does, right? The brute force. If I have how many neighbors I'm choosing, algorithm depends on it, right? Uh, Performance of a algorithm depends on how many number of points I am taking. Or they are talking about this time complexity. If they are talking about time complexity, then in brute force, either way we are calculating all the data points, the distance of all the data points. Then in that term, the k value might not affect anything. But which performance they are talking about? Scoring. Okay, we'll see. Like which performance is there. I have to ask someone who created this. Okay, so which of the following can be used to evaluate performance of KNN model? Which model? You should have mentioned it, but okay. So we can get accuracy score, right? Root mean square errored. In regressor, we can get it. And R2 also we can get in regression model. But what is misclassification error? There is no such metric, right? Misclassification error. I haven't seen any misclassification error metric before, but okay, it is essential to. Okay, let's go to second question. Based on the following statement, select the correct option. It is essential to perform feature normalization before performing KNN classification or regression. Yeah, true, right? Because it will reduce the computation. It works on Euclidean or any distance formula, right? So if they are very far away in one dimension, then there's possibility that it will show that it's more farther than the other point. If one dimension scale is very huge, uh, then it might change the distance from data point. The distance metric used in KN may be sensitive to relative scales of the feature. Yeah, this is all, which may prove problematic for data sets having substantial discrepancies among scales of individual features. So statement one is true. Both are true. Okay, so does statement two correctly explain for statement one? So this is sensitive to relative scale. That's true. Which may perform because this one is the right answer. As k increases, bias of a KNN regression model increases and variance decreases. Bias means unable to fit the training set. So if I have more number of Ks, then there is a possibility of misclassification. So that's true. And variance also should increase in that case. Uh, Model, okay. Bias can regression model increases, and okay, my biases increase. Uh, just my variance is all variance decreasing. Yeah, I guess it's true. Kane model highly sensitive to noise and outlier for low value of K. Noise, yeah, true. Both are true, but does it explain? No. Bias or variance is not explained by the noise or anything. The reason is reason decision boundaries, right? It will form simple decision boundaries and all. Outlier has nothing to do. Okay. What will be the result of the following Python expression? Something they wrote. Okay, so we are using nearest neighbor function. We are choosing three neighbors, okay, fitting on x train and then predicting some x test what will be that. So nearest neighbor gives us coordinates. We can actually do this. Okay. Okay, so let's say this is the one we have. To get connected in that. So fit sample. So for us, they told us use 3. Where it is, piped equal to and neighbor dot fit xtrain. So I'm naming this as xtrain for simplicity. Okay. And nearest neighbors is neih neidh dot fit xtrain. And this is fitted x dot train. No, it's not x dot, it's x train. Okay. Okay, so my model is fitted. Now they are telling us why spread is equal to gh dot predict, and I'll use something to predict samples. We can use x train also. And what is x? This or not? It doesn't have any predict. Yeah, sure. It doesn't have any predict thing, right? Because it's not an algorithm. It gives you some neighbor of all the data points and all. This is all it does. So error occur neighbor object does not implement predict method. Okay, I tried it and I got the error. Okay, they are asking us what could be the possible predicted class obtained for point x, which is this black one, I guess. By perform k and n with Euclidean metric and k equal to 1, means I will only consider one neighbor for voting. Then this blue one is 3 uh, scale apart, and this red one is 2 4 plus or 8 under root 8. Root 8 means 2 root 2 apart, and 2 root 2 is less than 3. So this red one is nearer to this black x. So red. What will be the result of the following Python expression? Okay, run this. Return distance true x test something, but I don't have. Wait, the miss. They deliberately missed it, or they are checking, because otherwise we'll get a error if this is not a you know, if this is not deliberate, or like this is a mistake, then we have to check other thing, but otherwise we'll get error and not enough value. Maybe then value error will not get. So I'm hoping that this is not a deliberate one. This is a like mistake by someone who wrote this one. Okay, I will fit and return distance. Okay, B are initialized with the two nearest neighbor of x test respectively. A gets initialized with values, while B gets initialized with distances of the two nearest neighbor. So uh, first we'll get from this is I guess values, and so we'll get indices from this. We'll get indices value, and so have you anyone run this code? Like should I run it? Let me run it now. To just write x train. That's all. Return distance. Okay, neighbor. Fitting happen of strain with neighbor equal to 2. What? Okay, it's telling me to give me 2D data. To is I'll just put another square bracket around it, and maybe here also same thing. Okay, what I got? 0 1 indices, 0 2. Okay, we'll see what we got here. This is from video, so somebody if you have maybe watched the video correctly, and what they are asking specifically, it's in there. It's okay. If I skip it, you get indices that we got. Well, A gets initialized with distances of the two nearest neighbor of x test. We got indices, so let me check this one. That's what we got, right? Indices. We'll see. Consider the following data set. Okay. Normalize the above data set using min-max scalar and predict the target value corresponding something. So we have to predict on this using KNN. Okay, let's do it. Okay. Okay, so I'll make data x is equal to x1 and x2. So means 1000 comma 0.5. Likewise 2000 0.6 3 990 comma 1 5400 comma 0.7. Okay, so there y is 11 comma 20 comma. Okay, now they are telling us to do and predict the target, normalize it. Okay, I will normalize it from sklearn dot preprocessing import min max scalar. I will make a class object of it. To normalize it means I have to do is scalar dot fit and transform it of what x. Okay, so how it will look like. Scalar is okay, it will look like something like this, and I will store it in something like x transformed x trf. Okay, so I'm storing it in x transformed. My data set is now scaled. Then I have to do is to predict on this using KNN regressor with k equal to 3 and employing Euclidean metric. Okay, from learn neighbor. Import KNN regressor. Okay. Oh, okay, and then no, it's not the one. So wait, what I can do is import neighbors. Then I can look what is there in neighbors. So this is the one we need. K neighbor regressor. Okay. Then I can do something like this. Model equal to neighbor like this, and I have to write and 5. Oh, sorry, not 5, 3, and Euclidean metric, which is guess. Metric. Euclidean. That spelling is correct. Euclidean. Okay, that's my model. Okay, so I'll do model dot fit x transform this one xtrf. I'll use comma y. Okay. Metric parameter. Okay, so this one is the real, the correct spelling. And now I have to predict from it. Model dot predict, and I'll predict 1700 and 0.2. Okay, 29. 29 is the answer. Any doubts in this? No, right? It was very easy. Okay. I guess. What? 24.33. I use 3, right? Neighbors are 3. Yeah, metric is Euclidean. Metric is Euclidean. Regressor is also there. I normalized it. Then why is it showing the problems? Y's are, I copied it. 11, 20, 42, 16, 25, 0.5, 0.6, 0.3, 1, and 0.7. List doesn't have it. Okay, then I can do is correct only, put it right. It's still coming 0.2 or 29 only. I made mistake of not show error. Okay, neighbor regressor is there. Euclidean, I did scaled it, transformed it. Yeah, so it's transform data. Then what is the mistake? It should be 29, but it's showing 24.33. Does anybody know? Does anybody got this answer? 24.33. You tried it and got this answer. Because for me, 29 is the answer. I did get everything which they asked for. Regressor only I used. The Euclidean metric is the one I used. K is equal to 3. Does anybody got this answer? 24.33? No. Yes, no.
No, sir. No, can we try with k is equal to 5?
No, but they told
Sometimes
us
it
to
may.
use A equal to 3, so that's why I'm
3.
using.
Okay, okay.
Yeah.
But 5 is the default
5 is the default one, but
value.
they are asking us to use 3. So that's why I'm
3.
using. Still, it's getting 22.8.
22 only. That's a difficult.
Well, is the 29? I'm getting 29 as answer.
Oh, that may be a mistake
So,
in the key.
yeah, maybe mistake in this. So that's why I'm asking. Does anybody got 24.33? No, right? Uh, Nobody got this answer. Then we can ask them. No, ask him how he did or she did. Okay, let's go to next one. Which of the following method can be used to handle large data files in machine learning? Stream data or use incremental loading, which is true. So this Hadoop and Spark, they are using in big data. So they are platforms to handle this large files only. So I guess all of this means this too. Scale processes large data in batches and update the model parameter for each batch. And aim for incremental learning is for the learning model to adapt to new data without forgetting its existing knowledge. True, incremental learning is a dynamic technique which is applied when training data becomes available gradually over time or its size is out of system memory limits. Yeah, both are correct. Both are correct. Yeah. The following standard implements partial fit method in regressor. So linear regressor doesn't use. We can't use partial fit on that. Only SGD regressor can. Uh, Ridge. No, no, not ridge, not polynomial. The ridge. Yeah, because it uses stochastic gradient descent, not the normal gradient descent. That's why this we can use partial fit on this. The following estimator doesn't implement partial fit method in classification. Doesn't implement logistic regression. This was given actually. If you have watched this large scale machine learning, then uh, this was given in that. Stochastic gradient descent can deal with large data sets effectively. True, we can break the large data set into smaller chunk and process them sequentially using SGD regressor, which means we need only one chunk into memory at a time. Yeah, this is also true. Okay, count vector converts a collection of text document to a metric of token count. To, yeah, counts the. So token means you can say word or like that, and it will give you count of each word. Count vectorizer does this. Okay. Mark the correct statement about count vectorizer and hashing vectorizer. Count vector does not store the resulting vocabulary, but hashing no, it's not true. Hashing vector does not store the resulting vocabulary, but counter yes. In counter vectorizer, each token transform to a column position instead of adding to the vocabulary, but hashing vector does opposite. Mm, right. Hashing vector is a good choice if we are falling short of memory and resources. Is a good choice if we need to access the actual tokens. Yeah. So in hashing vectorizer, we don't store the tokens, so it will save us some memory. And when we need the actual tokens, if we are required, then counter vector is a good choice. Yeah, we do not force matrix size explicitly with count vectorizer. The matrix size is based on how many unique tokens are found in the vocabulary. Um, yeah, true. Actually, so how many tokens we get, that much bigger our metrics will be. So if our let's say if our paragraph contains many different kind of word, then it will form that so that size of metrics. But we can set some rules, set that ignore some question, something, ignore it and take something into consideration, something like that. We can set the rules, but still we can't uh, we control the size. Count vector and hashing vector. Okay, so means they are asking which is the correct way to write this. So this underscore doesn't come in anything. So from sklearn dot model, linear model, no, linear, from feature extraction we can import this count vectorization and hashing vectorizer. What is the shape of matrix? Text document. Where is the text document? Sorry. Is there any text document? Or they are asking to uh, oh wait, learn dot feature extraction dot text code it was uh, count, right? Count is C dot fit transform. Maybe they are xmet. Okay, fit transform dot. Maybe they are text document like that. Let me mistake. Itable overrow text document. No. Which xmet they are talking about? Does anybody have any idea which text document they are talking about? Text
No,
document.
sir. It was confusing. I could not do it. Actually, there was no text document given.
There is no text documents, right?
Yes.
So then, how will we answer this? Mm, that so one means I got one sample only, and 19 different words are there. So likewise, so four samples are there. So right. So four sample means, so let's say if our paragraph, or let's say uh, usually corpus, something like this is used. In this, I have like one, uh, some data, some text, some text, right? One, so like that. So if I have, so this is one sample, like that. We use in while fitting it, right? Uh, so 2, 3, and 4, like that. So if I this thing is telling us that we'll get 4 rows when we do when we use count vectorizer, but it doesn't tell us how many columns we will get. So, but still we don't know what is the text documents. So I can't answer it. Mm, okay. N features transform text, but which text? Print shape. Same thing, right? We don't know the we don't know anything about this text. So is maybe is it's related to this video. Does anybody have watched video in that these things are there, text or something like this? Uh,
No,
okay.
texts were not there. Four text
Okay. We'll see. So in
sample was there, but it is not this text.
okay, then we'll just skip those questions. And in hashing vector, build analyzer method is used to. So build analyzer works is how we, so this is the like return a callable process to process input data. So let's say we inputted data, right? Then how we processed it, like means how it got converted to this tokens and numbering. So if you write this, no, build analyzer method, then it will give you this answer, like how we did it. But okay, process the text before tokenization. You can actually, or you can actually search it on sklearn also, it's there. Build analyzer, build analyzer, return callable to process input data. Okay. So what should we do about this too? We can skip it. See, so 1:10. Okay, whatever. Can't say. This one we got correct. Okay, maybe all of them are correct. Okay, I'll see what should be done with this too. I'll talk with someone who has created this, like why these questions are there. Let's go to 7.6 SVM. Okay, so which of the following code will throw an error? Uh, the best thing is run them, but let's see which one can throw an error. So from sklearn import svm, which is true, so it will not throw error. From sklearn import svc, which is false. Uh, from sklearn we can import svm, not svc. From sklearn.svm import svc. Yeah, this one is true, so it will not. It will also not throw error. From sklearn import svm.svc. This will throw an error, but we can run it if you. It will throw an error, yeah. Invalid syntax. Okay. Which keyword is used to Used to set regular parameter in SVM classifier, which is C. Which is following module confusion matrix. What does the method SVS score return? It uh, returns accuracy. It returns accuracy, right? Specific sensitivity, precision. No, it returns accuracy. Consider the following code of classification. Okay, I'm using scaling, and then I'm using something called linear this support vector classifier. Hinge loss is okay. I'm using C equal 100. If this leads to overfitting, which of the following values may overcome the problem of underfitting? Okay. So what C does is it tells us how much this the error part will consider it. So if we have high value of C, means we are giving more focus on the error. We are giving more weightage to the error. Okay, how much penalty, how much we should penalize? We are more penalizing more. So that's why it's overfitting. So if I reduce it, so there's one thing like so I'm not penalizing much now, which can solve the problem. May overcome means and multiple. So then C equal to 1 will also solve it, right? It will solve this problem, but we'll see how C equal to 1 will work. Yeah, it will make it will solve C equal to 1 will solve this overfitting problem. Right, yeah, it does. Okay, do not output probabilities of each for each class. Uh, do not output probabilities. Um, Actually, this question should be little bit more descriptive because we are dividing the data with planes and we are telling which side are you on, and we are not actually calculating any probabilities. So maybe true. Okay. Pipeline same as the book code. Linear SVC C equal to 1 I'm using now, and loss is hinge. Okay. Alternate way to same code. Okay. So C equal to 1 and linear, of course. And in SVC, I guess the default loss is hinge only. So that's why this one. So they are like kernel, linear, and RBF. Uh, so here they are using linear SVC, so kernel should be linear. Features 3. Okay. Standard scaling. I'm doing it. Linear SVC C equal to 10. Hinge. Losses hinge. Default. It will fit the training data using support vector machine. It will transform the training feature to degree 3, then will fit the data using SVM. It will normalize training data using standard scalar. It will do both of this, right? Scaling also does, and transform to 3 degree also will happen. It will transform the training data to degree 3, normalize it. Okay. Okay, then this is the answer, right? Consider the following code. Assume that all the necessary libraries are imported. Okay. I'm making a pipeline. I'm using SVC. standard scaling, then SVC, or gamma is auto, kernel is polynomial. Which of the following? Which will be the degree of polynomial kernel function? So by default, polynomial kernel degree is 3. You can check on this sklearn website. Okay. What is the default value of regularization parameter used in SVC classifier? 1. But for a support vector machine model, let xi be an input, and okay, and if this one is great, this is a function is greater than 1, where w naught and w are the estimate parameter of one, then xi is a support vector. No, it can't be a support vector, right? Because this equal to 1 is a support vector, but it's only giving us greater than. So it's not, xi is not a support vector. Equal to 1 is a support vector. Is not a support vector. True is an outlier. Can't say with depending upon the other data points, xi may or may not be support vector. No, it can't. So using, because this equation holds, so may or may not is not a question. It's not a support vector because equal to 1 is a support vector. Which form method is used to get the indices of support vector? Indices of support vector. Maybe this one will be there. Support. I don't know. SVC. What is this? Hinge loss, linear SVC, new SVR, normal. Support vector, intercept, kernel trick, decision trick. Here, okay. Support something we want output, and feature name and iter support. Okay. Number of support vector for each class. Indices of support vectors. Yeah, support. So this one will be used. Support. Which of the following method is used to get the number of support vectors? It was here only. N support. Number of support vector for each class. Okay. Sure. Consider following code. I'm using NUSV. Okay. Then where x and y are the feature metrics, and label vector value, which kernel is used in the above classification? So I guess by default NUSVC using RBF kernel, but we can cross check it. SVC kernel default is RBF, so that one will be called RBF. Which keyword parameter used in NUSV to set the upper bound on the fraction of margin and lower bound on the fraction of support vector? Alpha no, gamma no, maybe nu is the answer. For different input data sets, okay. Okay, which data will be classified using the Gaussian RBF kernel? So this one, right? One. When you can like see a circular kind of things, in data set contains in a one like cluster and circular form, and then around it rings are kind of rings, you can see it, then it usually get classified better with Gaussian, this RBF kernel. 15. Okay, which one got the wrong? this one. This is telling us that only 10 is the answer. Oh no, 1 is also answered. Because you want that it doesn't overfit. Okay, let's see. I'll check it later. Okay, I guess this is last assignment. Okay, suppose that we want to classify MNIST dataset using linear SVM. Okay, then what will be the missing attribute in the following code or snippets? What is the linear SVC, right? SVC, or using linear SV. So linear is already given. So that's why it's not linear SVC, but SVC only. Which of the following parameters will control size of radial basis function? Size of radial basis RBF being controlled by gamma, I guess gamma. What will be the output of the following code? From some keras, we are importing MNIST dataset. Okay, I guess I have to run it. Uh, 6,000 28 by 28. 60,000 28 by 28. Okay, so I'm getting 60,000 samples in 2D. So this data is in 3D format. Means 60,000 samples are there, which contains 28 columns, but they are also 28 inside also. Like means on the third direction, we are getting in third direction also 28. This is a 3D feature matrix. Extrain only, right? Yeah, 3D feature matrix. So what usually we do is, when we train our models, if we get something like this data set, we convert this 28 and 28 to means one vector. Means we will make 28 cross 28 columns, and then we'll input all the columns in our train while training in any classifier. If we get something like this in but this is from keras. Okay, what will the following code implement? We are doing scaling, then I'm using classifier, then I'm fitting, extend, widen, fine, extrain, widen, and I'm using two validation. It will give a accuracy of extrain, which is learned using linear. No, it's learned from linear SVM. It will give recall. It will give accuracy of extrain, Yeah, hello. Hello. Yeah, sorry guys. There was a power cut here. So that's why my yeah, hello. Yeah. Wait. Just one here only, right? Okay, so where was I? Sorry, in 7.7. Yeah, here we did solve this. Use SVC and the gamma. This one is the answer. Okay, what will this code implement? Will be accuracy using linear SVM. Linear SVM on X train. Non-linear SVM. No, it's learned using linear SVM. This is a feature. Okay, sorry. Select the options. So this is the feature matrix we got, and there are some options. Actually, 4 samples of digit 5 are classified as digit 0. So this is the predicted labels. Okay. Uh, exactly 5. Mm, exactly 5. Predicted as 0. 0. Sorry. No. 5. 4 samples of digit 5 are classified as 0. Yeah, true, right? Because it predicted as 0, but it should be 5. So 4 times it happened. Actually, 2 sample of digit 4 are classified as 0. 2 samples of digit 4. Digit 4, no, 0 is there. So nobody was misclassified as 0, which should be 4. Actually, 180 sample of digit 3 are misclassified. So digit 3, 182, 188. Sum of all of this is coming more than 182. No, so this is also not correct. Exactly 25 samples of digit 3 are misclassified. Misclassified, right? No, sorry. Yeah, so I have to sum it up. The other one, 1 plus 1, 2 plus 6, 8. 8 plus 6, 14, 15. 15 plus 7, 22. 24, 25. So this is also true. Okay. Filling the missing attribute, kernel. So this is the one they are asking, blank kernel. Okay. Seconds. Okay, all are correct. Let's do the. Okay, so somebody has problem with this.
Yes, sir.
Problem with the.
I was asking about that. No,
Okay.
this chunking.
Okay, chunking, right? Okay.
Actually, in the
Yeah.
no, my question was that, sir, in that demonstration, it was the chunking was done while it was reading from the CSV file. But when we get data, separate data, how we have to chunk and how we have to access it? That I not knowing. I don't know actually. So I cannot do some questions also in practice assignment and graded assignment. That's why I was asking. How that chunking is done, it is not actually.
Yeah, hello. Sorry for that. This power cut happened again, so I'm joining from uh, two different
Okay,
directions.
sir. Okay, sir. Sorry.
Okay. Okay. Sorry. What were you saying, Shashi Kumar?
Sir, this chunking actually dark data in these questions, practice and assignment questions, it is given to access this chunking.
In assignment
But in the
question.
video, it is only during that read. Yeah.
Uh,
No, yeah, I don't know. I just want to know how this chunking is done and how to access that afterwards. No, it
okay.
is when the demonstration.
Okay. So
It,
let's say
uh,
so let me
uh,
get some data from somewhere. Download CSV.
practice assignment is having data, sir.
Dataset is there. Dataset is there, right?
In practice assignment also some data is there.
Okay, Week7. Where it is? This one.
Some
Which
questions it is there, some data.
7 point, so should I solve this also 7.1 and 7.2?
I cannot. Okay, you can solve that problem. But the big data problem, one problem is there, I think, in the practice 7.2, maybe.
Okay. Then
If you solve, it will be
let me
helpful. Thank
solve
you.
7.1. We'll reach 7.2 and I'll solve it. Okay.
Oh,
Uh,
okay.
okay. So they are asking something text data is there. Okay, I'll copy this all.
Hmm.
This is the one, right? Yeah, this is the one. Pasting it. So text data is a array. So 9. So we have 9 samples in this. Okay. But they are asking us
Okay.
to use count vectorizer. What is shape of text data after
How
vectorization?
vector system?
Okay, so I already imported cvec, but let's do again.
Yeah, yeah. This I have done.
Cvec is equal to cvec dot fit transform
Vector transform
text
vector.
data, and I'm storing it in something data. Okay,
Okay.
they're asking us to tell the shape of it. Shape will be 999. This one 999. Okay. What is a token
Okay.
associated with metaverse? So token will can get using something
Yeah.
called cvec dot vocabulary.
Do-
Vocabulary. This one. They are asking for which one? Metaverse. Metaverse, not meta.
Metaverse. 51.
Metaverse is 51, right? This
51.
is the token associated.
51. Yeah. Okay.
Okay, 51. What is the shape
Okay.
of text data after vectorization? After the term that appeared in less than two documents are ignored. It means they are asking us to ignore. So which appeared in less than two documents, ignore them.
No, no.
Which can be done.
That is not clear, sir. That's not
Okay,
clear,
okay.
sir.
So there is some parameter. So if you use cvec, right, there is something called mean,
Hmm.
something mean df or idf, mean df. Yeah, this one. If you set it something, let's say 2, means if so how many data we have? 9, right? 9. So if some words are there in 2 or less than 2, then they will be ignored. We will not calculate count them. We are ignoring them. We want the words which are appearing more, uh, because there will be too much vocabulary. This is a small example. If we have huge vocabulary, huge this text data, then it will form a huge amount of this you know feature feature matrix after this transforming data. So that's why we can use something like this. So ignore if a text is not coming in more than 3 documents, 4 documents, or something like that. Okay. So now same thing. See, uh, get 9 and 20. 9 and 20. Okay. So means we are only getting 20 columns. We are now considering. So earlier we used to we got something 99 columns we got, right? But out of in 99, 79 were the words which aren't coming in like more than 2 documents. So they are in, let's say, this document, and maybe in this, but not in other documents. This other 7 documents. Some words are there in some this one and this one, but not in other documents, like that. So we are excluding those words, and we are getting only 20 words. We can actually see which are uh, we are getting. So we can use vocabulary, and sorry, not data, right? Oh yeah. So these are the words we are getting. So the token assigned to it, metaverse, is 7 now. So token is not the count. Okay, count token is not a count. Count is data itself. Data itself is a count. Will show no dot. Okay, so on the 7th this column. from 0, 0, 1, 2, 3, 4, 5, 6, 7. This is the one of metaverse. This seventh column is representing metaverse, because I know that it got seven number from here, vocabulary. So this seventh one, 0, 1, 2, 3, 4, 5, 6, 7, this one. So this is coming in first one time in first document, then one time in second document, and one time in third some. So say this like fifth document. So this is first, second, third, fourth, sixth, fourth and sixth document. This metaverse word is coming up. Okay. Okay.
Okay.
Okay. Then
Got it.
move for doc. This one. Okay. Yeah. Doc. This one. This features means these words are there, sentences are there. Write a code to convert the vertex into an array after tokenizing using counter with 10 features. We can't select actually features because, but let's see, cvac dot transform box. I'm getting pass array. Actually, I can write two array here, and I can see what the array looks like. Uh, this one is the one, right? Should I? No. Sorry. Now CVAC is why this answer came because this considering mean df equal to 2. Maybe so this is not the condition which was given here. That's why this thing is coming. To remove this again, so means I have to make another object of this class. Then this is the answer. 0, 10 rows, 10 features. So 10 columns are there, right? Where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. And 3, of course, because 3, this. Oh, sorry. Again, there was a like the power cut happened, and so you got it right. The how you got that 10. Maybe I should use this one.
One row is for one sentence, isn't it? Dogs. It is treating as this is the first question is treated as one document, is it?
क्या था? Okay, I'm sharing it from this one now. We got the answer right. Okay. Rewrite this. So this is the answer 0011010101. Okay. Let's see, week 7. This is week 6. Practice assignment 0011010101. Nobody is matching with this one, right? 00110101. No. 002. No. So this is the answer. Okay. No.
Sir, can you show the correct?
Okay, should zoom it a little.
So this it is one row No, corresponds to the one sentence, isn't it?
Something for define a function called k closest in Python with the following signature. Okay. X is set of vector, P is test vector, also given k is equal to 1 for this values. What is the output of the function? Okay, I can copy it. I'll define it. Define
Okay.
k equal to 1. Okay. Define. They want me to return the closest vector out of this. So a closest vector. Okay, for this output, use appropriate SQL method. So for that, if I want vector and all, then I have to use nearest neighbor. So first, let's do this. I already did it. Nearest neighbor is there. I will just create it. Let's create this. N neighbors equal to 1. Okay. Then what should be done is copy this feature matrix P and K equal to 1. Okay. And this is X. Now NEIGH fit work on this. It does actually fits NEIGH dot K equals something I got. It is neighbor bound method. Okay, this are the things I got. Metric feature names, fit, get params. So what params I'm oh, and samples, indices, and features, and jobs, and neighbors. One. Yeah, true. Okay, I set it that. Which one to use? So this. So they want me to return the closest vector in X, which are closest to vector P. Use the appropriate sklearn method, which is closest to P. Okay, which can be done using something like this. K neighbor, something return distance true. Already fitted it. So I have to write something like this. And neith dot context 10. I will use p. Will give me this one. So array 2. 101 is the distance and array 2 indices. So second one, 0 1 2. This one 20 47 88 is the nearest one. We got it using this thing, but now they are asking us to make a function. So what will I do is import, let's do this now. Everything should be there, right? From sklearn. Okay, here. On something like this. Okay. Then I'll make a function, sorry, object of this, and I will write k, no, n neighbors equal to k, because that is, and I want to return, no, first, then I have to fit it, neigh dot fit what x, I have to fit the x, and then I have to return neigh dot k neighbors p.
Okay, P.
If I don't set it true, then maybe it will return this one. So let's see. Closest. I'll write x comma y comma k, sorry, not k, y p. And neighbors argument got wrong, and because I never, sorry for this. But undefined keyword argument and neighbor. Just spelling mistake is there. Still a spelling mistake. Bars, I have to use S. Okay, this is returning. So they want, for this value, what is the output of the function? But they want only indexes, not the other part. So what we can do is, can actually write something like a comma b, and I can only send a. Okay. Wait. What is the output of the function? Sorry. Am I audible, right?
Yes, sir. Yes, sir. Yes. Audible.
Okay,
Audible.
sorry. Yeah, hello. Am I audible, right? Okay. Where was I? I have to return this vector, right? So this second, which got the second this thing. So I'm returning actually the wrong thing. B, and I have to write X and B, X2. That's what I want to return. Yeah, see, we got 20, 47, 88. 20, 47, 88. This one. Okay. Now they're telling us to compute, define a distance in Python. Okay. And means consider distance. Recall that the mean square distance between this is this formula. Do not use any predefined function to calculate the same. Okay. And calculate this x0 for this all the other array. Okay. This. So what I have to do is I have to calculate this sample distance from this 1, 2, and 3, right? So what I can do is for I in range of x, for I range of x will give me three uh, three things, right? Yeah. For j in range of x0. Uh, let's print to check what am I getting. Okay. Only scalar integers. What happened? Why? Fine range of x. Sorry, length of x, not x. Length of x. Same thing here. Length of x0. I'm getting all this 1000 and all. So what I have to do is in each step from this I have to subtract this one, this x0 same index component, and so means cost. So they are telling us to calculate means cost distance, which is minus that and power some p, means cost p. Yeah. So so this is the formula I am trying to apply. This one. Okay. Yeah, this is the formula I'm trying to apply. So for each step, I will do is first I will something I will take as a variable which will store this sum. So I'm just naming as total, or I can write like that. Okay, and then for every step I have to subtract it and take the absolute. So np dot absolute will use, and then I will subtract x I j minus x0 j, and I have to power it. So power I will use double star p, which is not there, but we have to use p2. Let p only. Uh, okay, so I'm powering that also, and this all should be stored in distance. Okay, plus equal. Now for everything we have to take cube, means here square root means 1 by p power for every distance we calculated. Star star 1 by p. Print, so it will print after every 2 loops. Okay. I will remove this one. So I'm getting 0, 2, and 2. But they are telling us to make a function. So I'll make a function out of it. Just write def means cos k. Here I will write x naught p should be passed, and in that I will do this thing with it. Okay. I will not print this. Yeah, I will not print this, but I will store it in an array. So I'll make one array, okay, empty array, and array dot append this distance thing. Okay, and I will return that. Return array. Why is that a problem? Okay. Here this should be inside this. Should be here. Should be here. Okay. Now I will do this call to just run this function. Okay, I'm getting 0, 2, and 2 as answer. 0, 2, and 2. Yeah, this one. Now load the data set from load digit. Okay, and use software regression to build the model using the following steps. Okay, load data set from sklearn load sets port. Sorry, port load digits. We'll see what they're asking. Load the data set and split it into in using train test split by keeping test as 0 and random 10. Okay. Then I'll use a return y equal to x and y. Shape, shape. Shape is good from sklearn dot model selection. Will import train test let and from model section will make 4 variable x train, x test, y train, y test. To that variable will to this object, and this object will take input x comma y comma test size, which is 0.2, and random state also, random state, which should be 10. I'm trained test standard scalar is scaling function to scale the training as well as test data. Okay, I will do that from sklearn dot processing importing standard scalar. I'm making an object of it. Scalar is equal to this object standard scalar scalar dot fit train. I want to transform it also, so I'll write transform train, and I'm gonna store it in something called x train scaled. Okay, and x test transformed, sorry, x train scaled equal to scalar dot transform, and I will write x test. Okay, so I got scale data of both the use logistic estimator to set parameter sag to predict the output. Okay, this other parameter I have to I'm just copying it. Logistic regression. Okay. Dot linear model import logistic regression. Okay. I want multi-class, and this I will just name it as classifier. CLF dot fit train scaled y train. Okay, fitting will happen. What is the shape of features data you got in digit data set? Okay, what is the shape of it? So shape of it is 1797, 64. How many labels are there in the data set? So then for that I have to print something called y dot unique. Okay, this is not working because this is a numpy array. Then I'll write something called np dot unique. And I'll get I'm getting 10, 0 to 9, so 10. Now how many times 7 times label 7 is there in the data set? Then maybe value count will also not work. Uh, can do is as frame equal to true. I can do. So they are asking us to how many times label 7 appeared in the data set. We'll write y dot value counts. So 7 appeared 179 times. What is the accuracy of trend model on the test data set? So normally when we use score, it will tell us accuracy only. So let's clf dot score test on scaled. Scaled on y test.
Okay.
0.92, which is
912.
we got 923 something. Solver I chose correctly. I did scaled it, and I am checking it on scaled data only. Test data, of course. So let's write this. What is the F1 score value you got? Average equal to weighted. Then I will to import from sklearn dot metrics.
Confusion matrix.
Import
Classification report.
what?
F1 score. Oh,
Yeah, F1 score. Yeah. Uh, F1 score will take y true and y predicted. So y true I have, y test I don't have, y predicted. So for that I have to do y pred equal to clf dot predict
predict.
x test.
Okay.
I'll use y pred
Comma is
comma should be there, right? And average equal to weighted. They told us like use average equal to weighted. Yeah. 0.95. 0.95 up to how much I have to give?
no total.
9501. This one should be the answer for this. This is the correct one. All things are correct. So, okay, right? No. Why no? Oh, I should have selected this. I didn't select it. Right? 51. Yeah, we solved it, but I just lost it. Got
Yeah.
lost somewhere, right? Yeah, okay, so this is okay, right? 7.1. There is no
Yeah.
number. That was easy. Okay, let's do 7.2.
Yes.
So, how many questions are there? Five. Okay. Let a function compute score something like this to do the following on iris dataset. Write a yeah, write your code. Code keep in mind split the dataset into 10 tests with 70-30 ratio. Import assume data a model. Keep RBF and regular parameter 20. Gamma is auto. Take random set equal to 42. Training data and predict the computed model score using test data. Which of the following is the computer? So you will be able to do this, right? This is same, but
Yes.
just make a function.
Yes.
Okay.
Yes. Yes.
A press pipeline contain min scalar function called scalar or classified with parameter kernel linear something calculation score f1 score and mark the correct. This is all the same, right?
Yeah.
Nothing.
Yeah. This
Thing
can be
that
done, sir. This can be done.
this can be done, right? This same as earlier questions, like just
Yeah. Yeah.
do
Okay.
whatever they are telling us, and you will be able to figure it out.
Okay.
Data set, data set in 50 mark the correct. Same. Random state penalty L2 hyperparameters. So okay, let's do this hyperparameters. So maybe
Okay.
uh, this is not easy. That's why. Uh, okay, apply kernel reference parameters inputs and return the average score of the model with the below mentions parameter regularization this random state.
I respect.
Okay, so then I will use grid search CV. Okay, and
Hmm.
okay, that I have to write from sklearn dot model selection import grid search CV. Okay,
Yes. Yes.
so grid search CV will take a model name. Model is which model we have to take is SVC or R SVC as an estimator. Okay, I'll use this SVC.
Test VC. Okay.
Then, but I have to import it. So from sklearn dot svm import SVC. Then I'll use SVC as my model. But they're telling us to do something with it, which gives accuracy score for iris dataset. Okay, I have to import iris dataset also. Okay, I will import it from sklearn dot datasets import load iris. Loading it. I hope this is here. That's here. Iris. Okay. Right. X. Y.
Right.
And y.
True.
Okay. Then do okay and do print a split. Yes, I'm just copying it. On P and the rest 70/30 size 0.3. Nothing was told about random stat.
No.
Remove it for that. Which accepts the kernel and regulation parameter as input and returns the average score. Okay, meters. So I take kernels this and
No.
regularization.
5, 10, 100. That's validation 10.
Uh, so the thing is, so the thing is, I have to supply a params grid, params grid. In that, I will write this. So, which is a dictionary. Okay. So I'll write something as this and pass this array into that key, kernel key. In kernel key, I will pass this values, comma same thing with
See.
here. So here. Okay. I'll also give this. But what happened? Is equal to okay. For now, I'll just comment it. Params grade. Let's see. Is there anything they are telling me to do with the classifier?
Cross validation 10.
Cross validation only. So
Random
nothing.
state is given, sir. 42.
Random state. Yeah. Uh, Cross validation is 10 and random state is 42. But this was given for grid search, I guess.
It's such.
Okay, we'll see. Adams grid, right? This is what I have to pass. Adams grid, I can write something like this. Is SVC, meter is SVC, params grid is grid we made, and so the thing is we are not using pipeline. That's why this that underscore kind of thing is not coming. Okay. Then CV. CV is equal to 10. The random state something. No, not here. Random state is not there. So maybe they are asking for this one only.
Okay.
Okay, this is my parameter grid. And this is my grid search. So I will just name this all as GS. Okay. And let's see the GS. How the GS looks like. Params grid. Then it should be param grid. Okay. This is the thing SVC will be applied. These are the parameters. Linear RBF.
Okay.
I guess everything is okay. What? Which is the whole?
Accuracy score. Accuracy score.
Sorry, what?
Accuracy score.
Yeah, accuracy score will do that. So GS dot fed x train test. Input inconsistent number of samples. Oh, sorry. I have to use y train. Not x test.
X train and Y train. Okay.
Invalid parameter. Valid parameters are C break. C is there. Kernels. No, maybe I did mistake in kernels. It should be kernel. Okay. I'll use kernel.
Kernel.
Okay, our model got trained. Now I will calculate GS dot score X test on Y test 0.977.
977.
Maybe they are asking for train only, not the test one. Means train,
Right train.
train. That will come one. Didn't come
Answer.
one. Uh, or they are which is following option gives? Is the
Accuracy underscore score.
accuracy underscore score. Scoring equal to uh, right
Scoring equal to
accuracy maybe, or I have to import it. Epsilon dot matrix import accuracy. Accuracy is there, right? Some the name is there. Epsilon matrix for best accuracy score. Okay, this one accuracy score is there.
accuracy underscore score. Yeah.
Accuracy underscore score imported, and this one I will use here. Missing required value y true. I guess this doesn't take this thing. This takes. Let's see.
Score.
Okay. Mm,
Yes. There should be a space, sir.
yeah. Mat. Yeah. So these are the things.
Accuracy. It is called accuracy.
Accuracy, yes.
Yeah.
And use accuracy and accuracy score. Okay. Or maybe they are telling us to calculate accuracy score using this.
Yeah.
Let's do that. Our answers are not matching. We require y true and y predicted. So y test I have, but I have to predict y. Right?
Prediction you had done earlier. No. No.
No, I didn't do the for this one. So I have to do it.
Oh.
Y pred
Equal
to
to X.
GS
GS. So
predict. I will put
X test.
that will I put here y. So still 98 or 97 or maybe 90 it's
Okay.
coming. Right, 1.
98.
It's
Yeah,
very
yeah.
near to 1, but
Yeah, yeah.
only option give the accuracy of the iris dataset. The dataset is iris, right?
Iris.
Okay, let's Okay, so so this is the answer. Like I'm not running this,
Okay.
but just run.
Okay.
Let's run. No, let's last one.
Okay.
This
Okay.
one only. Okay, I didn't
Okay, sir. Okay,
do
sir.
this one.
Okay, sir.
Okay,
Okay.
so
Okay.
so you have problem with what? The
Yeah.
chunking problem, right?
Chunking. That is the.
Yeah, let's do
If
that.
you could explain. Okay.
So the thing is,
Uh,
from pandas,
mm,
I have to import pandas. Sorry. Import
yes.
pandas as PD, right?
Okay.
So when we do pd dot read CSV or any file and
Yes.
read actual function is there.
Mm,
Let's say some file name is there. Okay, let's say file
okay.
name is there.
Mm,
Dot CSV. Okay, like that file name is there,
uh,
right?
yes.
I'm running from this. So the thing is, this dataset contains very huge amount of samples,
Yes.
or uh, so very huge. This is very huge. So what should I do? I can't run all the things in my system.
In a one single run. No.
Yeah, in a
That is
single
it.
run. So the thing happens is, see, you are seeing that there is a RAM is being used here,
Mm,
something like
mm,
this,
mm, mm.
2.1 out of 12 GB, right?
Yes. Yes.
So let's say
Okay.
my RAM can only contain 12 GB, and if
Yeah.
the
Yeah.
data contains, let's say, 15 GB data,
So
uh,
it will not load.
it will not load. Yeah, it will take a very huge computing power. So I don't have it. So what should I do? I will make a chunk of it.
Mm.
So this pandas give us something called chunk size. Okay.
So while reading itself, we can make this chunk size, isn't it?
Sorry, what?
No, when we read a data file, then
Yeah.
at the time of reading, we have to define this
Yes.
chunk size.
Yes. Of course, because
Then only it
uh,
will load.
yeah, then only it will load, because the
Okay.
whole data set knows not loading itself. That's why we are using chunking. We are making chunks of it and loading it.
Okay. Okay.
Okay, so
Mm,
that's why this pipeline will work later on, help you with this, because let's say I've imported or I've loaded a chunk of it,
mm,
and that contains null values, right? Null
mm,
values contains,
mm.
and I have to clean it up, right? So
Okay. Mm, mm.
after each chunk, I will run this pipeline, which will remove null values. Okay.
Sir, may I ask a doubt now? Once the first chunk is loaded, no? First, when
Okay.
we give this command like this,
Okay.
if there are some thousand, I will just for an example I am telling, and if there are 10,000 samples, and
Okay.
if the chunk size is 100,
Okay.
there will be then 100 chunks, isn't it?
Yes. Yes. Uh, 100
100 into
into
100,
10,000.
100,
Yeah,
yeah.
100 into 100. Okay, yeah.
Yeah, yeah.
10,000.
So when we give this command pd read.csv, what is it doing? Actually, is it doing this first chunk or all chunks? What is it reading actually?
So, when we usually do pd.read CSV without any chunk size,
Hmm,
okay,
hmm.
this whole will be loaded in a one chunk. Means the whole file will be readed in one
Loaded.
chunk. Okay,
Okay.
but let's say if you want to load in, don't want to load in all one chunk, but we want
One by one.
now one by one, like small data set, a small
Yes.
number of samples
Yeah. Hmm.
are we want, then we will load it in chunk wise.
Okay, then how to access that chunk 2, chunk 3, etc.? Is it come
uh,
automatically?
no. So
That's what I'm asking, sir. That is not. I am not.
okay,
Uh,
so
uh,
the thing will happen is, see,
uh.
let me, I'll load one CSV file. Okay,
Oh, okay, sir.
wait a minute. uh, Load something here. This file is loading,
Yes, sir. Yes, sir. I'm sir.
but this is the name of the file. I will just copy it. So let's say this is it, pd.read CSV. Okay, I'm reading it. Okay, this contains 22 uh, 1000
22,000. Yeah.
2556 samples. Okay,
Yeah.
the rows means.
Uh,
So if I put something as chunk size equal to 1000, and it will load chunk by chunk. Okay,
okay.
so the thing happened is I got all the chunks here,
Okay.
but now you are telling how to access it, right?
Yeah. Yeah.
So the thing is, it gave us a array of it, array of all the chunks. Let me show it to you.
Now we have to give this command. This to array. Is it, or is it already arrayed?
No, no, it's already arrayed, but two array will show us there. So this, pandas IO parser reader something,
Oh,
like it got transformed into that because we don't want to see all the data set at once, right?
okay. Okay.
Or the thing is, it loaded. Uh, uh, so there is something called generator in Python. If you read no generator,
Generator. Okay. I have not
generator
heard about
in
that.
Python. If you read something like this,
Uh,
generators and all, so it formed a generator out of it. Okay, so
mm,
when you will use this generator when there is huge data sets are there, huge amount of something you want to save and
mm.
work with it, you
Oh,
will use generators in
generator.
Python.
Okay.
So it
Okay.
forms this generator kind of this object. Okay,
Okay. Okay.
then now it will only get accessed when we will call it. So how
Mm.
will I call it? I will use some like for loop and all, and I will call it. So
Oh,
I'll
you had
use,
to use a for loop, a program.
yeah,
Oh,
for loop I have to use.
okay. Okay.
Yeah, for data in this chunk,
Mm.
read means print the data dot shape.
Shape. Okay.
Means I'm just printing date shape
Okay. Okay.
for data in. Okay, so this will give us shape of all the, so this many chunks I got.
Okay.
Means
Okay.
so chunk means 1000
Or
samples.
chunks in the size of 1,000. Okay. Okay.
Size of 1000, yeah, size of 1000 size. I got
Yeah.
this many datas,
Data.
1 2 3 4.
Uh,
So each time I will take one and do everything like model pre-processing, scale,
yes, sir.
checking null
For that,
values.
we are now how we are addressing these number one, number two, or is it array that array index? That's what.
uh, we can, so the thing is,
Uh,
consider this as an array. Okay, you got the array of this. Okay,
okay. Okay.
you can see if you write something, write or dot the length will work. Okay. Text file reader has no length. Okay, then okay, no, it's not substitute. So
No, it is not like this one. Indexing.
it's not like indexing, but so this is a generator function. It's actually not an array, it's a generator.
Mm.
So uh, so, so can you see this?
Yes. Yes. Yes, sir.
Yeah, so see, this is a generator, right? Generator something. So
Mm.
we'll use for loop only to access all the data.
Oh, for value in such that name of that.
Value means this is just a
Oh,
name
sorry,
which we
variable.
use,
Variable. Variable. I know.
a
I know.
variable name.
Yeah.
It's not, and this is a generator. So this is also generator function.
Okay. Okay. So we have to give that name and access it, isn't it?
Yeah. That's how. Or you can use something called iterators.
Uh,
So this next x is there, right? This,
okay.
can you
Okay.
see this? You can use this.
Uh,
Uh,
generator
uh,
object. Okay. Okay.
yeah.
Mm.
So let's do this. See what they are doing is they are storing this generator function
The
in
name
X.
X.
Okay, we'll also do that.
Okay.
So this is the generator function. I'm storing it in
X.
It's X. Okay.
Hmm.
For now, I'm just giving it X, and then I'll just write next X.
Print X. Next print X.
Okay. Let's do first something this, and I'll write next and X. What will give us? So this is the array I got, right?
Oh, first it will come.
First
Okay.
array, yeah. And then when I will write next again, then it will give us next one.
1001 to next one. Okay. Okay.
Yeah, but so see, there is a pointer in this. Means
Oh. 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 Oh.
this ended at 999.
9999.
Now it's
Now
starting
any
with,
1000 will start.
yeah.
Okay.
We can actually reset also this pointer, that now it's pointing to second one. We
Second
already
one.
next it, so now it's pointing to third one.
Third one. Okay.
Right? We can
Okay.
reset this or that also. So this is called something called generator.
Generator. Okay, sir. Okay. Okay.
We'll use these generators in this. You can read this or this whole thing. It's like from geek.geek. Okay.
Okay, sir. Okay, sir.
Or anywhere you can read about generators. This same as generator. Whatever you can do with generators, same
Yeah.
thing you can do with this.
Okay, sir. Okay. Sir, I have one more doubt. Now, this is one we read from that CSV file, no? Now, if
Yes.
there is a normal data set already with us, can we
Okay.
chunk it like this? I'm not telling about a, data size of bigger size, but around 10,000.
Yeah,
Can
I
we
did
do this?
know. See, this is not a bigger one. This contains small one.
No,
Like,
no. This is just one we read it now. We gave this chunk size now. Is there any
yeah.
other method for a normal data set having that some data frame or authorities?
No,
Can we
see,
make it this chunk? That's
uh,
what I'm asking.
see, the thing is,
Mm.
this function is there because
Mm.
the problem happened is we are not able to load the data set itself. That was the problem,
Yeah, yeah.
right? So
Mm.
for that problem, we are giving this is the solution. So we made this kind of
Yes.
solution. But if
Okay.
some data set is there already there in your system, or you are
Mm.
saying that if there is it's there,
Mm.
then it's not required, right?
It is
Why
not
should
required, but one question it was asking to separate it in chunks. That's what I'm asking.
separate? Yeah, so that's what, no, see, that's why I told you watch
Mm.
this 7.5. Okay, not, sorry, not 7.5, means this large scale machine learning.
Yeah,
Okay,
yeah, 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 yeah.
what they
Oh,
did is,
there also in that video also it is read only. It is done when it is read. That
no,
data
no,
is
no.
read.
So what we can do is, let's
Mm,
say if we have data,
mm.
transform it to a CSV file. Okay,
Oh,
save
yeah.
it, means save it as a CSV file. How to
Oh,
save a data frame to CSV? You can search for it.
yeah, yeah. That I know. I know. I know, sir. So
Yeah.
you have to go back to CSV and then again come back. Then not.
Yeah. The thing is, yeah, we are doing this thing because we are not able to read this file in our one go. That is the problem. So that's why
Yeah.
we are doing it. But as
Mm.
an example to show you, to show you all students that how should be done. That's
Mm.
why we are doing it
Okay. Okay.
in the video,
Yeah. Yeah. Yeah.
or and telling you to do it, because we don't really want you to give you a real data set which you are not able to load it on your computer, and then on that you should experiment. That's why.
Yeah. 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 Mm.
Okay.
Okay. Okay. So when a data set is given and you are having it, you have to make it back to CSV and then may use the chunk size, isn't it?
Yes, yes, yes.
No other methods are there, no? This matrix manipulation.
uh See,
No, I.
you can make chunks out of it. There is no problem. See,
Uh,
this is the data set, right? The
uh,
loaded one,
yeah.
right? Let's say if I have 1,000 rows and all, and
Mm,
you want to make chunks out of it,
mm.
you can use some function, right? Df this scale this df something ilog
Yeah.
from Python, df.ilog, or slicing methods you can use, right? You
Slicing. No, slicing will give only this one, no, sir. Now
No,
again we have to
you
have
can
a
use
index,
for
no?
loop. You can use for loop, and inside that use slicing, and you use slicing as an index size. Means dynamic slicing. When use I, then raise I by some number, I plus 50.
Yeah.
So
Mm.
every time, every loop,
Every 50, this will make a chunk.
yeah, make a chunk, something like that. You can use some for loop and like that.
So on using a for loop and reading that it will be done, no?
Yeah, see, if we have the data, then we can do anything with it. Like making a chunk is not a big problem, no.
Mm-hmm.
Yeah, so chunk means dividing the data, that's all. Dividing the data, you already know how to do it using slicing methods and all. You can use for loops. If you wanna, slice many more times, like multiple times you wanna slice it, you can use for loops and all.
Okay, okay, okay.
Yeah.
Okay, sir. Thank you. I'll try it. I'll try it. Actually, there was that data was already loaded, and it was on the fifth or sixth manipulation. It was asked to make it in chunks. That's why I got this
Ha.
confusion.
That's what, no, change
Yeah,
it to CSV
yeah,
and then load it.
yeah,
Then do use this. This is the easiest way. But if even if you want to, because see here the question is like this, that's why you are confusing. But
yeah,
if I
yeah.
give you a file which contains very huge number of samples, you're
Mm.
not able to load it, then what
Mm.
will you do? You will use this one only, right? There is no
Yeah, yeah,
option.
yeah, yeah.
No option. It's not because here loaded one, that's why this question is arising, that what should I do if I
Yeah.
already have this loaded one and I want to make chunks out of it. You can do, actually you can make chunks manually, like for loop, use for loop, make
Mm.
chunks and
Okay,
train it.
okay, okay, okay.
Okay, or use like in train test split, right?
Mm.
There's something called train test split. In
No,
that test,
actually, in that question, the train test splitting was done before this chunking. So I think I have to
yeah,
do this
true.
on all these uh, train data, test data, etc.
Yeah, true that.
Mm.
We are not telling you to make chunk using train test split.
Uh, uh,
uh, just make chunks, like that's what the thing is. And
mm.
this is the like the real way to make chunking using
Yeah,
chunk
yeah.
size and read CSV. But if you
Okay,
want other way, you can experiment, like you can use some other thing which can, you just want to divide the data, that's all, right?
okay, okay,
There are many ways you can divide the data.
okay, 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 sir.
Yeah. Okay.
Okay, sir. Thank you, thank you. I now got an idea now. Actually.
Yeah. See, if we have the data in the system, we can do anything with it.
Actually, yeah, it's only because of the graded assignment problem I am not specifically telling you.
Okay,
But
okay. Yeah.
here in that, such a this manipulation was requested in the instructions. They had asked you to load the data and make it this train trace split, and after that they have asking for chunking.
Yeah.
That was
See,
the
it's not like that. We can, like, means whoever designed this question, he can also ask. He can ask you that
uh,
divide the data set in 10 different smaller samples, then train it. But that won't that won't suffice the purpose of this chunk size and all.
chunking.
Chunking, right? You will
Maybe
be.
only for
Yeah,
the practice purpose it was given. No, no, I
yeah.
don't know.
For practice purpose it was given, that's why you use this and all.
Okay,
Chunk
okay,
size
sir.
and all, yeah. Use pandas for that.
Okay, sir. Okay, sir.
Yeah, it was specifically like that.
Okay, okay.
Otherwise, see, if we have the data loaded in the system,
Yes,
there is
it
no
is
need.
already loaded. It is
There is no
loading.
need. Yeah,
No,
yeah,
not to actually do this. Actually, sir. I
yeah,
got it.
yeah, yeah. Okay,
Okay, sir. Thank you. Thank you. Thank you very much.
okay,
Thank you.
okay. Then, bye bye,
Okay.
everyone. I hope I solved everything.
Yes, sir. Yes, sir.
Uh,
Actually, one more thing I would like to mention that now when we
yeah, yeah.
discuss
Ask.
these questions, no, our answers and the answers in the portal is different. This is happening for this graded also. Last 2 3 graded assignments, I have mentioned it in that meeting also. My
Yeah.
answers,
I don't know why these answers are coming different. Actually, the thing is, I have to ask the person who created this question. I
yeah,
even don't know that he is currently working in this means this farm or not,
program.
program
Oh,
or not. But if he is, then I have to ask him that why this solution are coming different, and if there is anything, like, that solved this part where it is. So
yeah,
we
yeah.
have this solved assignment thing for this practice assignment we have.
Yeah.
but not for this activity questions. Maybe,
Yeah.
but maybe it's there. I don't know. But I haven't got access to that. I can say.
Okay.
Yeah. Uh, okay. We'll.
Okay, sir. Fine.
Okay.
Okay.
Okay, then I'll just close it.